right. Well, thank you so much for being here today. We're really excited to share with you a brand new webinar we're bringing to you today, all about 4 ways to boost accuracy and efficiency for life science research. It is hosted by Media Cybernetics, and we're really excited to get started. So we're going to dive right in. My name is Nick Beavers, CEO of Media Cybernetics, and I'm pleased to be hosting today and sharing the presentation with Tom Moyer, our sales manager for the Americas and EMEA. Really excited to have hopefully an informative conversation with you. And if you'd like to reach out to us afterward, our contact information is on the screen. And of course, you can always reach us at mediasci.com. Our agenda today, we're just going to give you a little bit of an overview about who we are, in case you're not aware, and this is the first time you're joining us. We'll talk about the solution that Media Cybernetics is the manufacturer of, a software product called imagepro. And also, we're going to dive into the topic today to really, I think, do a real great service to talking about efficiency. We believe that there are 4 key strategies that any imaging lab can utilize to boost their productivity, boost accuracy, and boost efficiency. And we're excited to share those with you today. We're going to go through 2 of those and then jump into some live examples. And then we're going to do the last 2 and jump into some live examples as well. Lastly, of course, if you have any questions, you can place those into the chat for this webinar, and we'll be happy to either address those at the end of the webinar or after the fact as well. So just a little bit about who we are. Again, in case you're not familiar, Media Cybernetics is a software manufacturer, and we're really excited to be speaking with you today because we really have been around for quite some time. But what you see of Media Cybernetics in this day and age is a renewed vision to advance innovation in partnership with the scientific community. We have a very rich history of working with our community and working with those in science, research, and even industry. But we've renewed that focus, and we're doing that with partnerships with a lot of collaborating labs where we can work together on providing really great solutions. And those solutions are focused on moving microscopy, moving imaging forward in a meaningful way. We hope to prove that to you in these years. Over the last few years, we've had some really exciting new advancements. As an example, over the last few years, we made some really big changes as an organization that facilitated this vision. First of all, really moving a lot more quickly toward creating solutions. We did that by going private, really removing a lot of the red tape inside the organization and removing anything that was a bottleneck for development. Secondly, we took a hard look at what it is we're creating. And as a software product, imagepro, one of our big desires is to not create a closed ecosystem. And even if there are aspects of imagepro that could be considered closed, they're on the radar for us to remove those, to really work toward a more open environment where you can utilize imagepro in a laboratory with a lot of other different pieces of software, different systems, and have something that could hopefully be an ecosystem for your lab. That's our vision, working to make sure imagepro in a lab is one of the most capable and utilized pieces of equipment from the software perspective. Obviously, this is a journey, and so for that reason, we're focused on innovating all the time. So one thing about us that's fairly new is a new initiative of ours to release brand new cutting-edge products every single year, at least. We've committed to this. We've achieved it the last 2 years. We're on track to do it again this year, and we're very excited about all the new things we have to bring you. Right now, we're going to focus today on what we released in June of last year and how that has made a huge impact on laboratory efficiency. That's our focus, and that is what we're going to talk about today, and we're really excited about that. Now, as a business that's been around since 1981, this means that for all those years, we've helped a lot of laboratories go from images to answers. And we've also worked with a lot of customers in really, developing incredible new technology and creating a lot of great research discoveries, over 150,000 publications to date, and that's just growing every single year, which does make us the largest independent software company. We're very proud of that, but we're also very proud of all the people who have worked so hard with us to accomplish it. We couldn't have done it by ourselves, and we're grateful to the community of users that have done such great work using imagepro. We are based in Maryland, and so Tom and I are talking to you from the great state of Maryland in the United States, and that is our home base, but we have really a really wonderful community of employees and partners all over the globe. And no matter where you're calling in from today, you can rest assured that we have someone nearby that is fully trained on imagepro, that has really great experience with it and could be of real value to you. So that's just my quick overview of who we are. If you'd like to learn more about us, feel free to check out our website at mediasci.com. We have a number of great videos that we're constantly trying to post on YouTube. Check us out at Image Analysis and also on LinkedIn at /Image Analysis as well. So that's it for me in terms of the overview. Let's talk about the software solution imagepro. And before we dive into our 4 strategies, we want to set the stage to help you understand what it is we work on day in and day out, what we work with customers on, and how these strategies really came about. It's because of the work we're doing and understanding the evolution of imaging, microscopy, and analysis, and how that technology has really evolved over the last few years, and how we are with imagepro really getting in deep and understanding exactly how we can create efficiency. So overall, what we create with imagepro is an end-to-end solution. Breaking that into 4 categories, we like to think of it as import, process, measure, and report. And so if I broke all of imagepro into those 4 categories, we try to approach it in a very stepwise fashion. The first thing is getting images into imagepro, and we can do that in 2 ways. The first one would be supporting digital cameras. We support over 150 different digital cameras to automatically capture, live preview, and do incredible things with all these cameras, from live tiling, which allows you to rapidly stitch a mosaic image with some latest updates in 11.11, incredibly fast, really high quality, great new live tiling, a very competitive product if you look at what's out there and available today. And for the price, you honestly can't beat it. Real-time deconvolution, again, one of the top deconvolution algorithms in the market based on autoquant deconvolution. One of the pioneers of deconvolution, available as a real-time, really almost no impact to frame rate while you're live viewing images and then while you're capturing. A really beautiful image restoration that allows you to see in real time how your images should actually look. Multi-channel capture for multi-channel fluorescence, and we work together with CoolLED to actually support automated capture as well. But any light source that's an LED can be controlled manually as well. Does a wonderful job, and pretty much with any camera. In addition to capture, we support a lot of file formats, over 65 plus file formats from all kinds of different vendors across all of the EM providers and also across a lot of the optical providers as well. We support the open standard OME TIFF, and we work very hard to ensure OME TIFF we push it as an open standard. We think it's a great format, and we really support the work that they're doing at the Open Microscopy Initiative. And we think that moving forward, we'd really love to see a lot of these vendors all move toward that as well. However, imagepro is going to work with what we see out there in the lab. And the lab has a lot of different file formats. There's a lot of different cameras. Your lab may have every single one of these brands or just a few. That's why imagepro is so important. It works as well as we can possibly make it to ensure all of these brands are supported. Now, once you get images into imagepro, there's processing capabilities and a wide variety of them. You can do deconvolution, post-process, and this can be 2-dimensional, 3-dimensional, whereas the real-time is working on that individual 2D frame in real time. This is working on the full stack. So obviously you'll get a lot more information to be able to more accurately reassign intensities. Not a life science image, but a great example of how on the left side to the right side, you can do incredible stitching and shading correction of even some of the worst type of shading problems, and we can handle those. And then of course, simple things like just background correction, subtraction, and cleanup of images. So processing, obviously, usually a fairly straightforward step. The measure step is what we're going to focus a lot on today, because that's where a lot of people find most of their time being spent. How do I do my segmentation? We have machine learning and AI deep learning, classification, phenotyping, and a lot more when it comes to measurements. So you can find different types of cells with all the different types of outlines, multi-channel, multiple parameters, and different ways of looking at your images. Today, we're going to put a focus on life science. And so you're going to see a lot of our focus being on how you would approach life science research using imagepro, especially in the measure step. Whether it's two-dimensional or three-dimensional, time-lapse, imagepro can handle that. And our last step is an end-to-end solution and kind of giving you the framework for where our information about our strategies comes from today is our report step. This is where charts and graphs, stats, exporting PDF templates, all of that's possible. Wonderful, beautiful, easy to use data, graphs, and reports, and many different ways of looking at the information captured from the measure step. This can apply, as we've talked about today, for life science, of course, but we also work in materials as well. For the life science side of the business, really the scale of the image is pretty irrelevant from an imagepro perspective. We can work with customers who are working on stained tissues and colonies, unlabeled cells in bright field phase contrast, fluorescently labeled cells in wide field confocal or multiphoton, and even heavy metal stained cells with an SEM, TEM, even FIB and serial block face as well. So regardless of the system that you're working with, an image comes off and a pixel's a pixel, and imagepro is able to work with it and do a really great job working with those images. On the materials side, if you just happen to have a lab that's multi-modal and you're working both in materials and life science, be aware, electronics components, materials, the composition, and even microstructure across all the different types of acquisition is possible as well. So with that being the framework for you today, understanding a little bit more about Media Cybernetics and the imagepro software that we create, we put together 4 ways that we believe and we've seen with our customers. We didn't just make these up. We actually we're talking to a lot of our customers day in and day out, seeing trends and seeing a pattern of ways that they've been very happy about the efficiency boost they've had. So let's dive right into what that means. But before I start, let's just say that our goal for today was to provide awareness to you. We think that there's a lot of ways to approach something, and we wanted to just propose today what we think is a better way. We think it's reliable accuracy. And if you can get reliable accuracy out of your analysis, it's going to lead to an efficiency. And so we're hoping to boost your efficiency today, whether you use imagepro or use another piece of software, whether you are just here out of curiosity or whether or not you have really serious goals of improving the accuracy and efficiency in your lab. We hope that these 4 things are going to make an impact. So let's start with number 1. If you haven't considered it and if you aren't already using it in your lab, AI deep learning for segmentation is an absolute game changer. You've probably heard about AI. It's all the buzz. Everyone's talking about AI right now. But what about AI deep learning? So the first thing you got to know, if you're not already incredibly familiar with this, and I'm sure we have a mix of people in the audience today that are, some are incredibly learned about AI, they know everything, and others who have heard tangentially about it, but maybe just haven't had the time to look into it. So at the highest level, artificial intelligence is a technique that enables computers to mimic human intelligence using logic, if-then rules, and decision trees. It's a very broad term. And what fits inside of the AI term is a number of different things. There's actually quite a few, but let's just go through 2 more. Over the years, starting around 1980, machine learning became a pretty hot topic, and a lot of people were digging in and learning and researching about what could we do better in artificial intelligence. So a subset arrived that included complex statistical techniques that enabled machines to improve at tasks with experience. So the big change here was adding the ability for these statistical techniques to have experience. We took that one step further in the 2010s with deep learning. This was yet another subset, but this time of machine learning that enabled the software to self-learn from data through complex multi-layered neural networks. So you'll see a lot of software out there that claims to be AI powered. They're not wrong, but what it might mean is that they're machine learning based or just some other type of AI. And what we're going to talk a lot about today is deep learning. So it is important when you're looking at options, Again, it doesn't have to be imagepro, but when you're looking at different plugins for freeware or you're in the market for commercial products, ask them if what they're using is deep learning. It's actually going to make a big difference, and we hope to show you today some of those differences. This is all about that multi-layered neural network. And so this is what one of those neural networks might look like. Obviously, they take many different forms, but the idea is that you have inputs and outputs to these layers. And each one of these layers has nodes. Each of these nodes, say, well, what is a node? Well, each of these nodes is a very important aspect. The node is actually going to allow you to assign numerical values. And again, we're just speaking at this from the highest possible level and not diving in today, not really an educational webinar. So what we're going to talk about is just what does it mean to train? What does it mean to have these layers? And simply what we're saying is numerical values are passing from layer to layer. And they're the summation of all the inputs. So you're inputting information on the left-hand side, you're summing those inputs, you're creating a mathematical function that is then being passed on to the next layer and to that next level of the network. And when we do that again, we once again sum all of the learnings layer by layer. And in practice, what that pretty much means is you just have a sequence of computations that starts to understand the inputs, and as you tell it the input that you have given it is correct or incorrect through training, it starts to refine the output. So just like you would as a young child learning something, you might call something the wrong name, you might point to the wrong thing, you might pick up the wrong block, you put the square in the round hole. Over time, when you're corrected and told enough times that that is correct and that is wrong, you start to learn that what is the right thing to do. The layers of these, what they're called convolution neural networks, CNNs, work in a very similar way. So how does it compare to other methods? Well, let's talk about a few of the other methods when it comes to segmentation. Manual drawing, intensity thresholds, machine learning. In imagepro, we call it smart segmentation, and of course, AI deep learning. Starting with manual drawing, let's just say we bring up an image of a cell, and we're going to use a simple one. These are just fluorescent images, holotomography, and these, so not fluorescent, my apologies, they're holotomography images, and these beautiful images of cells are fairly easy. They're just bright intensities on a dark background. I could manually draw this, of course. Many people have done that before. I could use intensity threshold, and I could adjust my histogram and find what is in my image. But is it really that simple? Matter of fact, if I just go back really quick, once I manually draw, I'm done. I am the convolution neural network pretty much, and I've actually been able to decide whether or not each one of my adjustments of my line was the correct thing to do or not. Because over time, I've taught myself. I've learned, like the convolution neural network has, when I should and should not label something. So without the convolution neural network of me involved, an intensity threshold really has no idea what is or is not supposed to be segmented. When I create an intensity threshold, I'm just looking at the intensity of every pixel, and then I'm grouping those together in blobs. Now, the next thing I have to do almost always, and if you've done segmentation before, you know this to be true, you have to maybe do an edge filter before even starting. You probably have to background correct before actually even starting. After you've done the segmentation, you have to split objects, you might have to filter it, you might have to delete objects that shouldn't be there. You might have to use some kind of a tool to adjust and bump out some of your polygon lines and correct the outlines. It can be a bit of a task. And so this is really just getting started when you do the intensity threshold. There's many, many steps to get this right. What about machine learning? Well, when it comes to segmentation, I can also segment, and I have to draw a bunch of little circles all over my image, and I can actually do that to give inputs for a recipe. I can give it reference objects and background objects for class 1 and background, and then I'll build this recipe, and I'll have this complex recipe that allows me to understand, based upon this recipe, how this image should be segmented. The only thing it's really doing here is removing my background correction step. It does a really great job of handling incorrect backgrounds, but sometimes I still need to prepare the image with edge filters. Might still need to do splitting a lot of the time. Probably need to filter out small objects. Probably need to delete objects that were erroneously found. And I might need to adjust an outline or two. If you've experienced this, you know. If not, I can tell you from experience with a lot of customers and years of doing this, it can take a little bit of time. Now we compare that to AI deep learning. And AI deep learning is a completely new method. It actually boggles the mind sometimes if you've never been introduced to it before. It is a different approach. It is no longer taking a multi-step process to prepare the image and segment it properly and do all these extra steps. You are doing all of that in what we call the training step. The training step is introducing to the model what it should find. And when it comes to instance segmentation, which is what we're mostly talking about here, that is going to allow you to find individual objects, and those objects are found or they're not found. Now, there's a couple of little options. You can choose your class name, you can set your targets and adjust kind of strictness and probability thresholds. But overall, most of the time, what you train a model for is what it finds. So all of these other things, filters, background correction, splitting, they're completely irrelevant at this point. You don't need them, and so there's no extra steps. So that's great. But what does that mean from the standpoint of accuracy? And so today we want to help you to understand the differences between these, because number one is, why should you use AI deep learning? We're recommending you should. Let's take an example for this electron microscopy image. We're looking for the mitochondria in this image. Now, to the naked eye, if you're incredibly familiar with what mitochondria look like in electron microscopy images, they're going to stand out to you right away. To most people who don't know, they may not even notice them. And to those who have done segmentation of these types of images, you know where this is going. So an intensity threshold, just you doing everything based on a histogram, is a nightmare. It's absolutely not going to work, as you probably know that. It's just going to find everything that's either dark or light, and it's going to have a lot of trouble finding the objects. If I applied machine learning, maybe through a lot of manipulation and a lot of hard work, I could get something that looks kind of like this. Maybe I find one, maybe I kind of find a few others, but it's going to find all the wrong things and missed most of them. And then, drum roll please, deep learning. It really is incredible. So I've trained the model on what mitochondria look like, and because of that, it's looking through my image trying to find an instance of a mitochondria. It doesn't care about the intensity. It doesn't care about whether the gray values are the same as other things or not. It's taking into account the context of everything around it, the entire image, and all of the rest, just like I would and how I had been trained on how do you find a mitochondria. There's obvious differences between the human brain and, of course, a CNN, but I think it is a really valid comparison, and it's more related to that than it would be, say, an intensity-based segmentation. So as you can just see here, accuracy, once you've trained a model of these different types of methods, it really isn't even a comparison, truthfully. So we're talking about efficiency today. Well, obviously, if I can more accurately find the objects, I'm already more efficient. I didn't spend a lot of time. But how much time are we talking about? So these numbers are obviously going to vastly be different between images, between users, between computers, between models. So mileage varies here, but just to give you an idea, we ran some tests just to kind of get the ballpark. On our first column, we have one image that has about 16 objects. Imagine it's something similar to the image before. Manually drawing all 16 objects could take you about 3 minutes, almost 4 minutes. Now, if I need to do that 100 times, that could take me almost 6 hours. If I did the same thing with intensity thresholding, about 17 minutes to do the segmentation times 100 images, about 28 hours. And if I did that with machine learning, I'd actually save some time, because machine learning is a little bit easier to work with. It does a little bit better. It eliminates a lot of the problems of intensity threshold, corrects for background. It can actually sort of learn through a recipe and be applied to each image. So that drops it down to about 7, almost 8 minutes, blending to about 13 hours. And lastly, if I used a pre-trained model. Now, am I doing a lot of work to kind of prepare it? We're going to talk about that in a minute. Yes, I am. However, it's not that much work, and you only have to ever do it usually one time. And for that reason, I can click one button on a pre-trained model, and actually in 4 seconds for that image, I can actually have a result. Now, the beauty here is these models are incredibly flexible. So if you haven't used AI, one of the things that is a huge upside of AI deep learning is the flexibility from one image to the next. The problem with intensity threshold and machine learning is that they're not quite as flexible, or even at all as flexible, between images. So you're looking at just about 6 minutes, 6 to 7 minutes, where I can have 100 images beautifully annotated and marked up for what I'm looking for, my target objects. And it doesn't even really compare. That 17 minutes required me doing edge filtering, background, initial threshold, and object splitting, filtering, deleting, correction, kind of adding all those things up. The machine learning actually included edge filters, 30 seconds, background correction, filtering, deletion, all that the same. So I have to really take into account the complexity. And just to say it again, if you've done this before, you understand just saying, oh, threshold it, or just use machine learning is almost never the end. Now, let's just state the obvious. Everything I'm saying here today is talking about images that might be a little bit complex, looking at the image I showed just a moment ago. So these types of images are obviously going to be incredibly complicated, very difficult to analyze. If you're working with very dark objects on a white background and they have a really simple shape, then obviously we're going to recommend you use intensity thresholding. That makes a lot of sense. So today, if you're working with fluorescent cells and all you're doing is bright nuclei, DAPI stained counting, you can probably use threshold, just an intensity threshold. But a lot of us are not doing that. A lot of us are doing much more complex things. And so for that reason, we ought to figure out how we can use AI deep learning. And the trick here is trying to figure out what is the right deep learning to use. So you may not know this, but actually when I say deep learning, if you just go online, you start looking for different convolution neural networks that are a type of AI deep learning that find objects in images, you're going to see many, many options. So we developed something called the neural engine, and we did this on purpose. We felt it's too complicated for people to try to figure out what to use. They can go find freeware, but then you have the complexities of freeware, the challenges of freeware. So we developed what's called the neural engine. This enables multiple deep learning architectures to work with the same user interface and workflows. And what it combines is three that we believe to be currently some of the best architectures available for life science research. And that is UNet, which is a very broad term, but Media Cybernetics developed a custom base UNet, we like to call it, that allows you to do segmentation where you're looking at areas, not objects. We also introduced StarDist, another really wonderful architecture that allows you to find individual objects, but the unique thing about StarDist is it can find overlapping objects. And the last one that does not allow overlap is probably one of the most powerful that we've seen to date, and that is CellPose. And all of these, we could dive really deep into the differences and exactly how they work, but today it's all about making you aware of what's out there so that you can give it a try and see if it can help you with your efficiency. We did some of the heavy lifting in imagepro, and we combined all three of these into what we call the neural engine. We believe this helps to make it secure and confidential. You're not having to upload, download things from the internet. They're all available right inside the product. We developed a really simple to use single interface, so you don't have to work with all three and try to learn all these different things. You can just use one interface. The outline accuracy is unparalleled. And as we're going to talk about a little bit later, all of these will easily fit right inside what we call a protocol. So this is kind of our approach. We thought that it was a really great way of easily sharing the proper architecture that can apply to a lot of different images in life science. Again, if you don't want to use imagepro, I'd highly recommend you check those out. A number of them are available in a lot of different packages. Not many packages are including all of them in one. That's kind of one big unique thing about imagepro, but they're definitely out there for you to use. So let's talk about number two, and then we're going to dive into a live explanation of some of these things. And our second efficiency strategy is to use pre-trained AI models combined with fine-tuning. So we talked about just generally using deep learning, but this is different. We're talking about pre-trained AI models, and then we're combining that with not just pre-trained, but one that can be fine-tuned. And this is a pretty important point. So first of all, what is a pre-trained model? Well, pre-trained models pretty much just mean you're adding labels to the model. I take an image and I manually, or in an automated way if possible, mark up the image and provide it ground truth labels to say, this is the output I'm looking for. As we talked about before, You have the different layers of the convolution neural network. You have the inputs and the outputs. So I'm going to input all of my layers and all of my labels to tell it this is what I'm looking for. And then when I introduce a brand new image, it's going to use its knowledge of the labels I previously trained it on to look for things that are similar. And by doing so, I am now able to start all the way on the right-hand side of our little a chart here. And so basically what we have is on the far left, the most difficulty, on the far right, the least difficulty. Predicting pretty much just meaning finding the objects in your image with an AI deep learning model. The word predict is used. Prediction is the most efficient. A single click. If it knows the objects you're looking for, you don't need to do a lot of work. The pre-trained model specific for your types of cells and your type of image modality is going to be the most efficient. Moving backward from that would be to predict with a model that isn't familiar with your images and objects, and then to do some fine tuning. And then even worse than that would be models that are openly available. They've seen images, maybe an object similar to what you're working with. There's maybe thousands of different versions of them. They're constantly changing. They're on many different websites, and there's all these model zoos out there. They're fantastic, and we have nothing but positive things to say about how the community is working toward incredible new ways of working with AI deep learning. But for your lab, if you'd like to be efficient, working with the model zoos, if you really know what you're doing and you have someone highly trained in that, they could possibly be efficient. But what's the most efficient is to have a model that already has seen something similar to your types of images and to use that as a starting point. And then the worst of all of them, of course, is having just a completely untrained model that starts with no knowledge whatsoever and no inputs that you have to actually train from scratch. Now we're talking about having to give it thousands upon thousands of objects to really get going. So predict with pre-trained is going to be the most efficient method. Another thing to consider when it comes to efficiency, uploading time, downloading time. So if you're working with software right now where it does require you to use the internet, you have to upload things to train in the cloud, download those, then apply them to some software, and then, I have to fine tune again. I have to go back up. Obviously, if anyone's done that, you feel the pain and the suffering. So it is definitely better if the model training is local, not cloud-based. There are options available for that. imagepro is local. We actually deliberately made a decision not to go cloud-based. We thought it was inefficient. And there's a lot of software out there that thought cloud would be the best way to go. There are some things that are positive about it, but you have a lot of concerns as well. So just a consideration for you that if you're looking for efficiency, uploading, downloading, cloud time, knows what the internet's doing today, that's going to also impact your efficiency. So if I'm using a pre-trained model, what happens if it doesn't work the first time? And that's where fine-tuning comes in. Fine-tuning is pretty much just the idea that you would run a pre-trained model and see how it does. Does it find my objects? If I missed a few objects, I simply label the objects that I missed, retrain it, and then run it one more time. And because I've given it the information it didn't have, it will now include that the next time it does the prediction. It's as simple as that. Now, just to give you a sense of what we did, and when it comes to life science models, we are creating a growing list of models. And so what we started with many more to come, fluorescent cells, and this is an incredibly versatile model. Fluorescent dendrites, not tracing, but this is just object identification. It will find the dendrites incredibly well, and it will allow you to get areas and it'll allow you to have outlines around them. Same thing when it comes to retinal blood vessels, fluorescent nuclei, overlapping nuclei in fluorescence, a very broad tissue stain model for nuclei, works wonderful on hematoxylin stained tissue, label-free full cells, and then the nuclei for label-free, which was previously an almost impossible task, a really difficult thing to analyze before AI. TEM, both mitochondria and nuclei. And again, everything electron microscopy, the gray levels are so similar that actually it causes a lot of problems for segmentation models. Deep learning has been a game changer there. And lastly, holotomography, nuclei, and cells as well. So you can see a pretty broad range, and these are what we like to think of as starting points. If your image even slightly resembles one of these, they're very well going to do a wonderful job for you and allow you to quickly get started. And then I know we're not talking about it today, but just to let you know, we have 7 pre-trained models for materials as well. Titanium alpha phase, regular titanium, a versatile grains model, particle model, a pattern model that works on Widman-Stattman and other things, and then a number of different fiber models for electrospun and ceramic and glass. And again, starting points that can work on a huge variety of images because the versatility of each of these models is really incredible. So let's dive into some live examples and talk about number 1 and number 2, how AI deep learning can be really beneficial in your laboratory for efficiency, and then generally how pre-trained models can make all the difference, but really explicitly only if you allow fine-tuning to be the option as well. So let me pass it over to Tom, and Tom's going to show us how that would work in imagepro.
Awesome. Thank you, Nick. All right, so let's dive into imagepro, starting with the efficiency boost related to just utilizing AI deep learning as a segmentation technique. To do that, I'd like to highlight some other segmentation techniques, starting with manual outlining of objects. And I have a few different images open here so we can demonstrate each segmentation technique for various life science related images and applications. Starting with manual as a segmentation method. I'm sure many of us here have at one point in time had to hand draw labels on an image. Of course, when it comes to efficiency, this is really going to depend on A, the number of objects within an image that we have to manually label, how difficult the outlines are to manually draw. And you can see I can just continue on through this image. I'm highlighting glands within this tissue section. Again, depending on the amount of labels I need to add, this could take a few seconds if I have a single object, up to several minutes or hours, and that's compounded by the number of images where I need to manually outline objects. One thing to mention about the manual outlining method, something that we have heard in the past from customers who were previously doing a manual method for segmentation and moved on to a different segmentation technique, is that if you are sampling just a few number of objects from each image to maybe get averages, there is the chance to introduce some sort of bias here. And this could be a subconscious bias. Of course, if day in, day out, I need to manually label things within an image, over time, I'm going to choose the path of least resistance, which could mean I'm only going to label objects that are maybe well defined within my image area. So again, this could introduce some sort of bias. I could be outlining objects that are larger. Maybe I'm only outlining objects that are smaller. Certainly the most hands-on approach when it comes to segmentation. The next technique that we'll talk about is intensity-based or threshold-based segmentation. So in an image like this, if again, I'd like to highlight whether it's cells, nuclei, or objects within this tissue region like the gland regions, I can use histogram-based thresholding, intensity-based thresholding. And this is a fairly straightforward technique. I am just going to clip this histogram. I can work with individual color channels if that helps me out, depending on my image. But as you can see here, if I'd like to highlight maybe cells or nuclei within a region, because I have a higher contrast, I have these stained in blue, it's giving enough contrast between the red regions within the tissue that this would be an okay approach. But as you can see, based on what's highlighted within the image, I am picking up some single pixel regions. It's going to be hard to gate these out. I can do some pre-processing to the image to try to increase contrast between different regions. But this is something that I can do it once on a particular image. When I try to apply this same thresholding to another image, if I have any differences in terms of color values or intensities, it may not be a repeatable process. Moving on to the next technique, machine learning. Again, this is technically AI, but not AI deep learning. And we call this smart segmentation within imagepro. Now, machine learning does have a few benefits when compared to histogram-based thresholding. We can add multiple options into a recipe that can overcome things like different textures within a background. To a certain extent, maybe getting rid of outlines that are counting vignetting if we have some sort of issues optically with our microscope. So let's go ahead and try to find the gland regions using machine learning. So I'll just highlight a portion of the tissue here. I've got a region that has some of the blue areas and the red areas, and then I will highlight the background, which would be the white areas where there's no tissue present. So I can go through this exercise, adding additional labels to the tissue or the regions that I'd like to count, and then adding additional labels to the background. Again, I don't want to dive too deep into this technique. Previously, for most customer applications, we would have to go through a filter library, add multiple different filters to an image, pre-processing techniques, just to increase contrast between the objects that we're looking to highlight and the background. This can take anywhere from several minutes to several days. I have spent up to 3-4 days, 8 hours a day trying to compile different pre-processing filters and techniques before trying to use machine learning to highlight objects. Similar to threshold-based segmentation, this also introduces inaccuracies between images. Again, if we have any sort of intensity or color differences between images, I can spend a lot of time trying to create a machine learning recipe to highlight areas, and it may work on a single image, but now when I try to apply that to another image, it could completely miss the objects that I'm trying to identify just because I have variation between those images. Finally, let's look at AI deep learning applied to this image. Here I'm using a model that's had some slight additional training. This is based on our general objects model, and I'll go through that in a minute. All I have to do here is click on count. Again, this model has seen such a wide variety of objects in tissue-based images, fluorescence, label-free, and things like soccer balls, coffee beans. It's been trained to identify any sort of blob-like object within an image. All I have to do is click on count. There's nothing that I have to do in terms of pre-processing. And when applied to this image, it accurately identifies all of the glands within the tissue region. So moving on to AI architectures, again, this particular model is based on CellPose. We have UNet as an AI architecture, Stardust and CellPose present within imagepro. And they're all used for various reasons. They have their pros and their cons. So related to this image, let's take a look at these three models and why we would utilize them in this particular image. So again, CellPose we had just shown. CellPose does a great job at finding and separating discrete objects within an image. Next, we have the Stardust model. So Stardust also does a great job at finding discrete objects within an image, but it can also account for overlapping objects. So a single pixel can be dedicated to two different objects within an image. So here I've just run the Stardust model, and if I zoom up, you can see here I have two different objects overlapping and pixels in the center that are dedicated to both objects. So this is a great architecture if you need to account for overlapping objects. Lastly, we have the UNet architecture. Now, UNet is very different in that it's a pixel classifying model. We use this a lot for detecting different regions, whether that's tissue or any sort of image. And for techniques or applications where you're looking maybe for a percent area measurement within an image. It's also worth mentioning that UNet can actually account for multiple classes within a single model, whereas CellPose and Stardust are single class architectures. So in this case, I've trained a model to identify the red tissue or the pink tissue and the blue tissue. So you can see with the overlays here, I've got the red tissue outlined in red, the blue tissue outlined in blue. What UNet does not do a great job at is segmenting or separating individual objects. So it's great for finding areas, regions, patterns within an image, but it doesn't do a great job at separating those objects or areas. So with these three different architectures, we're able to create pre-trained models or apply these architectures for just about any segmentation, whether you're looking for areas, patterns within an image, or distinct objects. All three architectures are included to make sure that you can use AI and apply it to any sort of image. All right, let's take a step back and talk about using pre-trained models, applying those to our image, and then cloning and doing some additional training if needed. So if I go into the imagepro model library, I can view all of the pre-trained models that are available. Again, we do have some for materials, but I'm just going to highlight all of the life science related models. To apply any one of these pre-trained models to the image, I just go through the library and look for a model that closely matches in description the objects that I'm trying to segment within my image. In this case, let's say we want to find the glands within the tissue region. We don't have a specific pre-trained model to identify the glands, so I can use a very versatile model like general objects and see how that works when applied to my image. I'll highlight the general objects model and open this in the prediction tab. So I only have a few options here, one being setting the average object diameter. And I could do this manually, or I can run an automatic algorithm. It will go through the image and take its best guess as to the average object diameter within my image. All right, once that's set, I can click on Count. So this general objects model has been trained on such a wide variety of objects that it can really be applied to anything when you're trying to find blob-like images or objects. So you can see it's done a great job of finding a high percentage of the glands, but it's missed a few. So this is where I would need to clone this model and give it some additional training. If I move over to a different image here, we have a hollow tomography image. I will go through the library and let's try out the hollow tomography cells model. Again, following that same procedure, just make sure that my object diameter closely matches the objects that I'm looking to segment, and click on Count. So again, without being trained on this particular image, it does a great job in terms of its accuracy in defining the cells within this hollow tomography image, although it has missed particular cells and regions. So this, again, would be a case where we may need to clone this and add some additional fine-tuning and labels. Lastly, let's look at a multi-channel fluorescence image and use our fluorescent cells pre-trained model. Now at the top, I have segmentation channel options as well as a seed channel option. So particularly for multi-channel cell-based segmentation, it's beneficial to point to some sort of seed channel, which in this case would be the nuclei channel stained in DAPI, just to give the model some additional information to make decisions based on separating cells. So my segmentation channel would be FITSI, the cell boundaries, and then DAPI for the nuclei. And again, I'll click on count and see how well this model performs on my fluorescence image. Again, a very high accuracy, but it does pick up certain regions that we would need to clone this, fine tune it to ensure that it's not going to pick up incorrect regions in the future. So before we clone these models and give them some additional training, if you're just utilizing AI deep learning, but you don't have the ability to do any sort of fine tuning or additional training, at this point in time, it would be a manual process of adding manual labels, deleting things that it's found incorrectly. So having the ability to fine tune and train models, but still utilizing pre-trained to shorten the process and not having to start from scratch is highly beneficial. So in this case, all I have to do is click on Clone Model, and I'll give this a new model name. So I'll call this my gland model. I'll click on OK, and that opens our training panel. I'll change the colors here just so it's a little bit easier to see all of the labels. And we have some common tools available, a paintbrush tool, polygon tool, magic wand. As a starting point, I've used a pre-trained model that has shortened the time in terms of labeling because I have about 80% of the glands already correctly labeled. I can also use another segmentation technique, histogram-based thresholding, machine learning, whatever method I need or could use to shorten the time it takes to label all of the objects within the image, I have available. So it's quite simple to add some additional labels. I'll start with the polygon tool here. It's missed this gland region, so I can just manually draw this in. Now, within this image, I don't have that many labels that I need to add. Again, it's found a high percentage of the glands already. Let's say I have 10,000 objects within an image, and it's found 8,000. I still have to label everything within the image. I can't leave anything unlabeled, or else the model will train to think that those regions are background. If that's the case, I can simply add a region of interest. And now when I train the model, it's only going to take into account the regions of interest. So I can shorten the training time by just labeling things within these regions. So I've already saved some of these labels just to shorten the time it takes. So here I've added these labels to the image. Let's assume that I've manually gone through and drawn the labels in the image. Now I can add these labels into my training set. I'll make sure that the training channel is set correctly. If I have a seed channel, I can add that as an option. Once that's done, I can either move on to another image within the sequence, but I like to start with a limited number of labels. A lot of times the models train very quickly, especially if it starts out fairly accurate. I don't have to label a large number of objects. I can start by just adding a few additional labels, and then I can test this model out in the prediction tab. So you can see it took about 30 seconds, if not less, to train this model. I can now open it back up in this prediction tab and test out this new model on my image. And so already the model is accurately finding some areas that it had not found previously. So to test this out further, what I can do is just move to another image. Because I trained on the last image in the sequence, to be fair, let's move to a different image and try the model out. So again, it's much improved. If I have areas where it still needs some additional training, I can just click on continue training and continue this process back and forth until I have a model that's accurately finding all of the objects within all of my images. So let's go through the same process with the other two sequences or images, starting with hollow tomography. So again, I'll load my hollow tomography cells model. I will apply this to my image. We'll go ahead and clone this model because again, it's missed some regions. If I zoom in close, I'll see things that it hasn't identified. Maybe I need to update the outlines for things that it has found. So let's clone this model. I'll call this my hollow model. I will go ahead and apply new labels to the image. Again, assuming that I've taken the time to go through and adjust all of the labels correctly. I will add this into my training set. Click on train, and in about 30 seconds, I have a new model that I can test on all of my images within the sequence. The training process is the same, regardless of your image. If you're looking to outline cells or nuclei or using a UNet model, although the UNet model would just include the option to add additional classes, the process is exactly the same. All we're doing is just labeling things correctly and training the model. So let's apply this new model that I've trained to this image and see how well it performs. So you can see, especially in this region here, it was missing this cell completely. Now it's picking that cell up in the image. So the training is extremely quick, and without much additional training, it's accurately finding all of the cells within this image. Lastly, let's go ahead and clone our fluorescent cells model, add some additional labels. So fluorescent cells, my segmentation channel is FITC, seed channel is DAPI. One thing to mention too, this fluorescence image here, you can see we have a lot of noise in the background. This is something where if I were to use another segmentation technique, it would probably pick up some of the background. So I would have a lot of these single pixel or small objects in the background because those intensities match some of the areas within the cells that I'm looking to segment. And we'll call this one floor model. So I've saved these labels as well. We'll apply this to the image, add it to our training set. So training channel is going to be FITC, seed channel is going to be DAPI. I add these into my training set, click on train, and I can apply this, the newly trained model, to my images. So it's a pretty straightforward process. Most of the time, this happens very quickly and usually only requires one or two regions within an image for the model to accurately identify what we're looking for it to identify in all of the images. And there we go. So previously it was picking up some of these regions in the background, which could just be an out of focus cell. But because the intensities were sort of matching the other cells within the image, and if I zoom in, it's sort of a blob-like structure, it makes sense that the pre-trained model was identifying this as an object. But with some slight additional training, it's now ignoring those regions. So again, starting with just utilizing AI deep learning as a segmentation technique compared to other techniques, whether that's manually outlining objects, using histogram-based thresholding, or machine learning, AI certainly has its advantages when it comes to outlining objects. Then, using one of the pre-trained models, I can quickly apply that to my image, see how well it works. If I need to, I can do some additional training, and now I have a model that has been trained on my specific images and is highly accurate when it comes to defining the objects that I'm looking to find within the images.
Great. Thank you, Tom. All right. Well, hopefully that was informative and helped to clarify points 1 and 2. So with our remaining approximately 20 to 30 minutes we have remaining in the webinar, we have 2 more to show you. Tom and I are going to make sure to provide that information right in time, so we have a little bit more time for questions as well right at the end. So without further ado, let me dive right into number 3. So basically what you just saw was the segmentation step. You saw all about how to use AI deep learning, pre-trained models, and the ability to fine-tune those models for really getting phenomenal outlines. That right there is a phenomenal improvement to efficiency over other methods, as we've hopefully shown today. Now, how do we take it another step further? What we're going to suggest in number 3 is to streamline and automate your workflows with a protocol. Now, again, if you're not using imagepro, there's still familiar types of approaches here. There's a lot of other software that is available that will create a pipeline or a workflow or some kind of automation that will build steps in your experiment. Not everybody has it, but there are some out there. Instead of handling everything one step at a time or doing things in a very free-form manner, you can save a lot of time and a lot of energy by streamlining your entire workflow. So let's talk about that a little bit. What we've introduced with imagepro, our approach is the analysis protocols. Analysis protocols are basically taking your workflow of segmentation, classification, and analysis and putting them together in a way that is really easy to work with. We have a really simple method of just having steps at the bottom of the panel. You see number 1, number 2, number 3. Number 1 is always going to be the setup of your protocol. The last step is going to be your result step, where you establish how do you want to see your data? How do you want to export it? Do you want to report or not? What you want to see? What do you want to close? Et cetera, et cetera. It's all about wrapping up the entire experiment or that particular workflow. In the example I'm showing you right here, another thing that protocols do really well, showing how Tom was just doing a segmentation and then closing that model out and bringing up a new image, applying a new model, closing that image. It takes time to open images and close them. It takes time to load models and switch between models. And so what a protocol allows you to do is, in step 1 of segmentation, first find your cell body outlines, step 2, find nuclei. Now, I could do this 3 or 4 more times. I could find all types of subcellular types of material. I could look for mitochondria in here, and I could look for anything. I could not have cellular images, and I could look for all different types of materials, different classes of objects. And so I can run as many AI models back to back as I want. The other beautiful thing about protocols is not only can I find the objects, I can establish the fact that the first object was found, and then I can do operational steps between them. This is where you can get parent-child relationships. You can do find the cell body or find the nuclei, and then look for dendrites that are extending from it, angiogenesis analysis, many different types of things. And I'm going to go over a couple of those in just a moment, but this is where you're able to set up that workflow to create a real simple automation. So yes, what we just showed you is a huge benefit in terms of efficiency if you're using the other methods. But the analysis protocols allow you to standardize. And when you're standardizing, you can have those guided steps that anyone in your lab can use. So whether you're doing it or you have someone else sit down and do it, both of you are using the same standardized steps. That's really important. Number two, you can integrate the AI segmentation that Tom was just showing, we talked about. You can create your own pre-trained models, so that way you have confidence that your outline accuracy is going to be there. And then you can move on from that. Now we can actually just include that into our workflow. We can establish some instant reports that'll be created right at the end of the protocol. And then of course we can batch process. So these four things is what makes up the protocol. Again, there are other tools out there that are kind of similar. We've seen others out there that do a few of these things, do all of these things. Really just depends on what you're working with. In terms of freeware, you're not going to see a lot of that in freeware software. That's usually a commercial software availability with maybe an exception or two. And so because of that, just want to point out, we've really worked hard at trying to create a good library. Now you can make your own, but we recommend starting with what we have here, where for fluorescence, protocols that are built for angiogenesis and tube formation, cell apoptosis, autophagy, simple cell count, of course, morphology analysis, proliferation, colocalization, translocation, live dead analysis, simple nuclei measurements and count, and multiple ring regions around cells. We can do the same thing in label-free bright field for confluence and transfection. You can do scratch assays. And when it comes to bright field, you're looking at color deconvolution, DAB analysis, hematoxylin analysis, muscle fiber cross-section. And of course, as we talked about, many different modalities, even electron microscopy and holotomography, finding cells, finding nuclei, and subcellular as well. Now, again, not materials webinar, but if you're in a lab where you do both of these, either bright field or electron microscopy, you can handle composite materials, fibers, grains, layers, particles, phases, pores. All these things are available. And what is it? It's really just combining the individual steps of pre-trained models. And I saw a question in the chat. Thank you for that. How are these models trained? Where is the information coming from and that ground truth data? And the answer is everything in the life science library and in the materials library is made with images that we've worked with partners, customers, and open source images. Everything is publicly available and allowed to be used, and permission's been given. We really hold to that standard to make sure everything here is a approved image for training the models. And so everything here has been trained by Media Cybernetics, and we have been working with customers to ensure all of these get a really great first result. A lot of times you may have to do a little bit of fine tuning right after, but as Tom demonstrated, it's a real simple process. So number 4 is really running with that protocol concept to say, don't just use a protocol to not have to go step by step, but to allow you to kind of put them all together and run in a nice workflow sequence. But in addition to that, batch process. And also, while you're at it, make a custom report. And so again, the reason for this is an efficiency boost. When you batch process, you can do a couple of things that may not be very clear. The first one, without having to step through every single individual segmentation or classification or setting up your rules over and over again, this really saves a lot of time. Not having to go step by step. Hitting one button and it automatically goes through the steps is a huge time savings. Not only that, one thing that imagepro does and would be available to really any software would be parallel processing and really spreading out the load across your GPU, across multiple cores of your CPU, where what you could do is not open the image. Opening the image is actually a resource-intensive operation. Opening panels and running operations and showing overlays. You can get rid of all that. Everything can just be done very transparently, and it saves the processor, the GPU, a lot of time. Because of that, you're running not just one image, but if you select an entire folder full of images with thousands of images and you say process using my protocol and my AI models, all those thousands of images. I can actually run as many as I can possibly distribute across the GPU, CPU. I can start running them in parallel. So that can have at least a 3 times speed boost. We've seen more than that, depending upon your computer. But it really does improve, how you can more efficiently process. So really, it works with any number of images. It's going to work through them sequentially. It's going to grab as many of them as it can to run it once, but then once it's done that, it'll grab the next set. And it, of course, intelligently avoids erroneous files. So if you, were to be working with images, one concern you might have, I'm going to point it at a folder. It might have a Word doc in there or some settings files. imagepro would ignore those. So that wouldn't be a problem. The other thing it's going to do, of course, when you're batch processing, you're removing the human bias. So you set everything up with your knowledge and, of course, the bias that's important to understand the segmentation. You give it a bunch of different images so you're confident it'll work generally in a very good manner. And then statistically, you're able to look at everything, get a nice good output per image, and as many collections as you'd like, which would then allow you to have great statistical accuracy. Now, once you're finished that, the custom reports. If you want to save some time, establishing a report that gives you exactly what you want and making that template one time is going to save you time with having to format Excel and format all kinds of different types of documents later. So when you have a template, you can actually reuse it for multiple experiments, save it out as a PDF and share it easily. You can add your company logos, reporter names. You can add marked up images to it for reference, add individual object data, even add statistical data tables, and so much more. Pretty much it's endless what you can add to the reports. But for those two things, basically using a protocol and then automating to save time running it in a batch would be number 3 and number 4. So hopefully with those 4 things, that would really speed up the efficiency of your lab. And with that, let me pass it over to Tom.
Excellent. All right, so moving on to automating the workflow, we've touched on AI deep learning and how that can improve efficiency. But AI deep learning is, simply put, a segmentation technique. We have found objects within the image. We have outlines, a nice, pretty picture that we can print out and put on our wall. But most of us probably want to extract and compile data with all of our images. So this is where we need to create some sort of workflow or a step-by-step process to first find the objects within the image and then extract data from those images. So within the protocol library, again, we have some life science specific, some material specific collections that include things like cell-based analysis, apoptosis, autophagy, cell morphology, lipid droplets, everything that Nick had highlighted in the previous slide, and some more complex types of analysis like co-localization, neurite outgrowth, wound healing, etc. Let's say within this image, I want to apply 2 AI models. The first one to find glands or parent objects within the image. The second to find child objects. This could be nuclei, cells, something within those parent regions. I can start with one of the generic protocols, such as objects within objects. So if I load this protocol, every protocol has an initial step. Every protocol is also different, so it could include different steps just depending on what the type of analysis is and the number of segmentation steps that are included within the protocol. In step number 1, I can classify, or I can give names to the different classes. In this case, let's call this glands, the initial parent objects, and then we can say cell or nuclei for the child objects within each parent object. If you notice at the bottom, by default, I'm in what's called interactive mode. The first time that you're walking through a protocol, we need to make some adjustments. This could be pointing to different AI models or various configurations within each step. I'm going to walk through this the first time, make those adjustments, save a version that I can now use to batch process a folder full of images. Everything is guided, so in this case, I have 3 steps, and then I have my results step. In step number 1, this is a segmentation step. By default, it's pointing to that general objects model, the extremely versatile model. But because I've already trained a model to identify the glands within this image, I'll point to that model for segmentation. Click on count just to make sure that everything is set up correctly, and then I'll click OK to move on to the next step. And let's set these colors to random just so we can see the separation between glands. All right, everything looks good. I can click on OK and move on to the next step. Now, I have a couple options here, one being a minimum area threshold or some sort of threshold. This can be based on area, intensity. We have a very large library of measurement types that I can use to gate things out. Let's go ahead and reset this so I count everything within the image and apply to make sure that we're not gating anything out based on area. So a few other options. If I'm looking for area measurements on individual objects, I don't want to count things that are cut in half because they're touching the perimeter of the image. So we have an option called clean borders where if I choose that and I run this segmentation again, it's going to ignore everything that was touching the perimeter. In this step, I'm looking to point to a model to identify regions within these parent regions. Again, we've already trained the Stardust model to find these areas, so I'll go ahead and point to that model now. One thing to mention, especially with protocols, is that we can mix and match model architectures. So we can use a UNet model to identify tissue regions or any region within the image if we want that to be our parent region. And then we can use something like a cell pose or a Stardust architecture for the second segmentation step. If that model tends to work better based on what you're trying to outline, again, we have the option to use any model within the library for any segmentation step. So I'll apply that model, and it looks like I'll have to refresh this minimum area threshold here and click apply. All right, so now it's found my parent regions, it's found my child regions. And lastly, I have my reporting step. So every protocol has been pre-configured with the types of data that are output. So this could be specific measurement types. In this case, we're getting a total objects count, a count of the parent areas, a count of the child areas. This is all statistical information. I can easily add additional measurement types. So if I wanted to add individual measurements for circularity or any other measurement type, I can do that here. I can change the appearance of objects as well. So just to make this a little bit clearer, we'll go ahead and fill in the parent areas in yellow. And instead of setting the cell regions to random, let's just go ahead and point to a single color for this class. Now the goal here, again, I've walked through this process. I don't want to have to do that every single time. I want to now automate and batch process. So we have a few options. I can automatically create a report, and we have many different reports available. We have two options for each protocol. You'll see in this folder, single site and multiple site. Single site gives you a nice large snapshot of what's been segmented, and then the data collector table below. Multiple sites is a good report if you're going to batch process many images, and maybe you'd like to include some graphs to show measurements throughout the analysis. So I have one that I based on the general objects within objects protocol. And I'll click on this just to make sure that it's creating the protocol correctly. And it is. So I have a single graph, I have snapshots, and some statistical information. So I verified that this is all set up correctly. So automatically create a report, automatically export results to an Excel spreadsheet. And I'm going to save a version of this. We'll call this tissue analysis protocol. And I'll click finish. That will take me back to the beginning of the protocol. And I'll go ahead and delete all of the data that we acquired while setting up this protocol. And now what I can do is take this out of interactive mode, and you'll notice at the bottom, instead of the guided next step process, I now have the option to run this process on a single image. In this case, I have a sequence, so it will actually run through each image within the sequence, or I can run a batch, point to a folder full of images, and run that process on all of the images. So I'll go ahead and click on Run Selected. Again, you can see it's going to run that same process with all of the settings that I've set up initially on all images within the sequence. We set this up to automatically generate a report, automatically export results to an Excel spreadsheet. This is also something where if I need to make changes, I know we're short on time, so I won't highlight it's the same process again. If I were to take a look at the label-free holotomography image or the fluorescence image, it's all the same process. The guided step-by-step, configuring the protocol, saving a version of that, and now I have something that I can access at any time, and I know that it's going to run through that same process and give me accurate results. So you can see it's finished. I have my custom report. So I have child 1 count, so this would be the cell count throughout the sequence. I have my statistical information. If I need to add individual measurements to this report, I absolutely can. And it's automatically exported these results into an Excel spreadsheet. Let's change the column width here. And you can see it's easily extracted all of that data. And I can do this all with a single click of a button. So that's how we can start with any protocol. We can make slight changes, point to different AI models or any other segmentation technique that's available, and then go through the individual steps, configuring it, save a version. Now I have something that I can utilize to quickly analyze images at any point.
Great. Thank you, Tom. All right. So with that, I think we have wrapped up our 4 ways to boost accuracy and efficiency, and really excited about, I think, the 4 things that we went over today from our perspective and working with lots of different labs doing life science, materials, many different applications. We have found that in general, if you switch your lab over to AI deep learning, you're going to immediately see a boost just for the segmentation step alone. Secondly, the pre-trained models with the ability to fine-tune is really takes it one step further. Yes, you could train models every single time. Yes, you could, work with it to slowly work it into its, exact outline accuracy for every image. That's not efficient. So AI deep learning is great, but AI deep learning with pre-trained models and fine-tuning is going to give you the largest bang for your buck. Third, streamlining those steps. Segmentation is really just one step. There's a lot more that can be done, and a lot of times you might need to do it more than once. Streamlining those into a workflow using something like a protocol, big benefit. And lastly, of course, batch processing. If you can do 1 through 3 and then batch that across 1,000 images, you have so much more time to do other things. And so it really does help you to be more efficient and lead to great gains. And that's really what we're all about. We really appreciate your time today. And, if you're interested, if you're already an existing customer and you're using this, thank you very much. If you are not and you're interested and you want to give imagepro AI a chance to hopefully improve the efficiency of your lab, we'd be grateful for that. If not, and you're already using other solutions, we hope today was useful for you. But our imagepro solution does offer a number of unique things, all of which we've already talked about today, with superior outline accuracy, ease of use, secure and confidential, protocol ready, provides easy guided steps with AI integration, batch processing, and instant reports. These things all combined, we think, makes a really nice solution, and we offer that as a really simple package called imagepro AI for life science. It includes everything we've talked about here today. Again, if you don't have room for imagepro at the moment, we really hope you got value out of this. And otherwise, if this could be of use to you, we can definitely tell you that our team is ready to work with you to help implement some of the things we've talked about today and really try to help you. And the reason we do that is we really care about partnering with the scientific community, and so for that reason, we've offered success plans. I mean, brand new, we introduced last year, and it's going so well. We have phenomenal onboarding classes with every single one of our customers, starting with our standard plan, and then throughout the year, we offer technical support. Right now, we've been having wonderful conversations, getting lots of great results. The efficiency boosts of our customers with a success plan has really been phenomenal. So we're really proud of this. And funny enough, while standard is a really great value, and professional is a really great value as well, with additional software upgrade protection, meaning that you actually get the latest version of the software every single year at no extra cost. We also give you the latest protocols and AI models included every single year as they become available, whether it's at their time of release or in between. While these are incredible values, we've actually seen most of our customers choosing the ultimate plan. And the reason for that is they really love both standard and professional, but they love also being able to work with us and connect with us, getting uptime guarantee, licensed server support, and a bunch of training hours that you get for software, application service, and even if you'd like AI model training as a service, where our team will work with you to get the best possible model available, to get that good pre-trained model start. So this is available to you. They're available in 1 and 3 year plans. We offer all the services live and remote. And it really just gives you a nice peace of mind that can be renewed annually. A lot of benefits to this, and we're really excited that it's available, and we think it's really affordable in comparison to some other competitors that are offering not even as much for over $10,000 a year, and ours is a fraction of that. So we're really excited about this. If you'd like to learn more, obviously, you can check us out at mediaside.com and go over there, learn more about imagepro AI for life science. Click the Let's Talk button at the top and feel free to give us your information, and maybe we can set up a demo, and Tom would be happy to learn more about your particular application. Otherwise, we're really grateful for your time today. Thank you for joining us. And if you do have any questions, I'd be happy to take those at this time. So we'll just check really quick for anything that has come into the chat and see if there's anything that we can answer.
So a couple things. I'm trying to reply to these in the chat, but is it possible, this comes from Jacob, possible to measure linear objects such as distance between 2 points on the image, something that could help define position of 2 objects? Absolutely. We didn't have time to go through everything and all the tools that are available within imagepro. But after 43 years in business, we've had some time to include many different features and tools within imagepro, one of them being relational measurements. So we can use relational tools to find distances between objects, and I'm happy to demonstrate that. If you have a specific application, feel free to contact us, and we can go through your images and demonstrate those tools. So we do have free trial versions available. Again, you can contact us directly. We can go ahead and talk about your applications and then issue a trial license that you can test out yourself.
I do see a question as well that I'll answer, which is there anything new up on the horizon for imagepro? And I think that's a great question. What we can say is absolutely what we can promise, and we're really sticking to this. We are coming out with new products every single year. And so stay tuned. But there's a lot of exciting things going on. We don't announce when that's going to happen, but we are definitely always working on new capabilities. So we hope to continue to improve all the time. So that is definitely a good question. The answer is absolutely yes. And I think what you'll start to see from Media Cybernetics now that we have, as my very first slide said, really made a really deliberate focus on speed of rapidly getting new technology to the market. That's something that we're gonna prove.
So a question here about a subscription option. Currently, imagepro is available as a perpetual license. So it's a one-time payment. Again, who knows what will happen in the future, but currently that's how we offer imagepro. Stephen asked, any prediction models in the works? Again, always. We are constantly working on new pre-trained models. Nick had highlighted some of the options we have regarding success plans. Some of those options include any new AI pre-trained model or protocols that are coming out. We just released with a version 11.1.1 a few brand new models like the hollow tomography cells and nuclei, some fiber identification models in terms of materials applications, and then some updates on existing models like our label-free. We had a version 1 that was released when we came out with the AI version of imagepro. We released a version 2.0. So we just gave those models some additional training, and it's been an improved model. So always working on new pre-trained models.
Yeah, absolutely. And then I'll just add to that as well. One of the things we like to do, and we're actually actively doing this right now, we have been working on collaborative research agreements with a number of different labs, where the goal of the collaborative research agreement is specifically to work hand in hand with labs to train models that would be available both for them and to be publicly available. Obviously, at some point in time for certain types of images, and it's important to have access to those who are capturing them and who understand exactly how to give it ground truth data the best. And so that would be yourselves potentially. We'd be happy to do that if anyone's interested in any kind of collaborations. We're always looking for those, and we have quite a few that you'll actually be hearing us announce this in the coming months, actually. So that's always something to think about.
A few other questions. So for retraining the models, is an NVIDIA GPU required? It is. Although you can run the prediction and training on a CPU, we do have an option to turn off GPU enabled. It is not recommended at all. The time that it will take to even apply a pre-trained model to an image is going to be at least 10 times slower than with an NVIDIA GPU. It's going to be much worse when it comes to training. Training is a little bit more GPU intensive. We do have specifications listed on the website. That being said, you don't need a supercomputer to run AI deep learning or anything that utilizes GPU, such as 3D, that also utilizes GPU. Take a look at the website and the specifications for more information on what's required to utilize AI deep learning. If you already have a license, if you're an imagepro user, depending on the version that you have, AI deep learning is available as a module. So we can talk about upgrade options to the latest version and adding AI deep learning to your existing license. Let's see, Ram has asked, have you used this on ecological images, such as quantifying community structure in marine habitats, coral and oyster reefs? We actually have. So one of the benefits of being such a long-standing organization is that we have seen just about every single application and image out there, some that would absolutely shock you. We have imagepro is being used and has been used to identify structures within a pizza, to look at boils or pepperonis, everything from that to dolphin tracking and all of the common applications between life science and materials. But specifically looking at ecological images, we do have customers who currently use imagepro and AI deep learning for similar images and applications.
I think the big takeaway when it comes to AI deep learning is that it's not looking for cells. It's not looking for materials. It's looking for whatever it is that you've trained it on. So that's really the important thing to take away. If you're able to provide it some really good ground truth information, it's going to do a really good job. Now, one thing to keep in mind, the more different your samples are from the examples we have in our pre-trained models, the more information you're going to need to provide it. It may have been trained on things that looks very different from what you're training it on. That's okay. That means that you just need to give it a little bit more data. It might take, instead of 10 objects, 100 objects. So that's kind of one big rule of thumb, is that when your images look exactly like our demo images, you're going to be in good shape. It actually might work right away with one click. If they look incredibly different, it just might take a little bit more fine tuning. But in general, our experience is a little bit more fine tuning is really not a big lift. And compared to all the other methods we talked about, it is night and day in terms of efficiency. So I think you'd be really good. You'd be off, in a really good shape there to work with something that's more of an ecological type image. I think we'd be fine. I'll take this last one, which is Mac Linux support. So right now we're Windows based, and that is the current requirement. So I think we'll just stick with that for the moment. Future plans, can't really speak to those at the moment, but we find that a lot of labs, even to this day, and we'd love feedback if this changes over time, but a lot of labs do have access to the Windows. It hasn't been a huge impediment for us so far, and we're really, I think we're having great progress working with the Windows. So that's where we are at the moment, but totally understand the question. Okay, I don't think there's anything else that has come through, and I thank everybody for their time. If there are further questions, please do us a favor. Send those in, through mediaside.com to our Let's Talk page. Feel free to do that, and you can reach out to us. We'll be happy to get back to you, no problem. Everything here today will be made available as well as a recording. So if you'd like to watch it again, it'll be coming out here soon. But again, have a wonderful day. Thank you so much for your time, and we hope it was valuable for you. Goodbye.
Thank you, everybody. Bye.